Alright, so we're going to go ahead and learn about U-Substitution, which is a technique of integration. Sometimes it's called integration by substitution. And up to this point, we haven't dealt with any functions when we take the antiderivative of them that have an inner function of anything other than x. So U-Sub is very effective when we have inner function that has something other than just x. Like in this case, we have x cubed plus 6, and that's an inner function inside x cubed. Obviously, it's not just x. And another thing that you can tell this is great for U-Sub is because when you notice that this inner function, when you take the derivative of it, it equals something outside of there, then you're very, very stoked because you know that U-Sub is probably the right method to use here. Okay? So, and they're definitely look a little different at times, but here's one example. This one's actually perfectly set up for U-Sub. So once you've recognized it's U-Sub, you choose your U, and again, your U is generally going to be an inner function. It's going to be something that when you take the derivative of it, it equals something else outside of that inner function. So I'm going to let U equal x squared plus 6, and what I'm going to do in a second, I'm going to substitute U in for x squared plus 6. So my integral will then be in terms of U, so my dx is something that I can't have anymore. I need a du there. So how I get that, I actually take the derivative of this, and I use some weird notation, but I end up getting that du, because the derivative of u we'll call du, the derivative of x squared plus 6 is 2x dx. Since we took the derivative of x, we'll put a dx with it. And then I'm trying to substitute in for dx, so I'm going to solve for this. So it's going to be du over 2x is equal to dx. Again, I just divided by the 2x. Now I'm going to make my substitutions into here. So I've got the 2x is going to remain the same. Instead of x squared plus 6, I'm going to substitute in u. Instead of dx, I'm going to substitute in du over 2x. Okay? So with U-Sub, how it's going to work out, you're going to get something that's going to cancel out like this. You notice we have a 2x on the bottom, it cancels out with this 2x right here, which we have to have those x's cancel. We can't have two separate variables in our integral. We can only have one variable in there. So good, we just got u's now, we're stoked. So the new problem is going to look like this, or not new problem, but as I simplify, it's just going to be u cubed du, which is a very simple integral to do now. The antiderivative of u to the third is just going to be u to the fourth over 4 plus c. And then, since our original problem was given to us in terms of x's, we have to make sure that our answer finishes up in terms of x's. So right now we have a u to the fourth over 4 plus c. We can't leave it in terms of u. We have to just substitute back in our x's. So where I see u, I'm going to put back in x squared plus 6. X squared plus 6 to the fourth. Sorry about that, ugly 4. Plus c. And we're done. So, and of course you can always check your answer by taking the derivative of it, and it should equal that, and it definitely will in this case. So there you go. Okay, so we're going to take a look at another example here. Similar to this one, just put a trig thing in there to change it up a little bit. I'll go through a little quicker on this one. So again, I notice it's U-Sub right away because I see an inner function right here, and if I take the derivative of that, it equals negative 3x squared. Now, it doesn't perfectly cancel this out like in this case it did, but the important thing is that the x's are going to cancel. It's okay if we have a constant in there somewhere. That's not a big deal. So as long as those x's are going to cancel, we're good. So I'm going to let my u equal 2 minus x cubed. I'll get my du by taking the derivative is equal to negative 3x squared. So again, I just took the derivative of that, put a dx after that. I'm doing this to substitute for my dx. So I'll divide by negative 3x squared. Du over negative 3x squared is equal to dx. Now it's time to make my substitutions. So I'm going to go ahead and I'm going to substitute in, leave my x squared there. For this inner function, I'm going to let that be u. So it's going to be cosine of u. For dx, it's going to be du over negative 3x squared. And like I said a second ago, we should notice x squared right here, x squared right here, they cancel out. Now we are left with that negative 3 on the bottom, but that's okay, not a big deal, as long as the x's cancel, because now we just have u's left in the problem. I like to take that negative 3, which is on the bottom, bring it outside of the integral as a negative 1/3. You can leave it in the integral if you want, it's up to you. So here we have the antiderivative of cosine is just sine. So it's going to be negative 1/3 sine of u plus c. And just like we did over here, we're going to have to go ahead and finish up by plugging in our u back in. So it's going to be negative 1/3 sine of 2 minus x cubed, yep, plus c. Okay, let's go ahead and take a look at going to go ahead and take a look at another example of U-sub. It's similar to the first couple examples we looked at, but both of those had polynomials as the inner functions. This one just has a trig one as our inner function this time. So when I look here, this cosine of x plus 5 is the inner function. The sine of x is outside, so I notice that, okay, well, cosine of x plus 5 is the inner function, so I want to kind of test, see what would the derivative of that be. Well, the derivative of that's going to be negative sine. So that's a good thing because I have a sine out here and that'll cancel. Okay? So I'm going to go ahead in this case, let u equal cosine of x plus 5. I'm going to find my du, which is going to be negative sine x dx. I just did that by taking the derivative. Now I'm going to go ahead and substitute. My sine x is going to stay there on top for right now. Inside the square root, instead of putting cosine x plus 5, I'm going to put u. So I'm going to have square root of u. And then, oops, I forgot up here to solve for my dx. Let me go ahead and go over here and do that. So I'm going to divide by negative sine x. So it'll be du over negative sine x equals dx. So where I see dx, I'm going to replace it with this, du over negative sine x. Alright, so now, like I said with u-sub, it always has to work out that you have some canceling out, so you're only left with u as your only variable. I have a negative left there, so I have to make sure I don't forget about that. I'm going to go ahead and put that outside the integral right there. And this square root of u on the bottom I'll rewrite as u to the negative 1/2 to make it easier to find the antiderivative. So now I can just find the antiderivative of that by adding 1 to the exponent, which would make it 1/2. Divide by that. Same thing, dividing by 1/2, just multiplying by 2. So this is, the antiderivative of that is going to be negative 2u to the 1/2 plus c. And then I'm going to go ahead, and my last step, like I've done in the last couple, I'm going to take cosine of x plus 5, plug it in where I see u, and I'm finished up. There you go. Alright, another way that U-sub works real well is when you have something like this. It looks a little different than before. I've kind of been hammering this thing in. If you look at the inner function, you take the derivative of it, and it cancels out with something outside. In this case, it's not going to happen because the inner function 5x, you take the derivative, it's going to be 5. There's really nothing outside to cancel. But the key is that the derivative of the inner function is just a constant. And there's no x's outside that need to be canceled, so it still works with our u-sub. So you can just let u equal 5x, and then du would equal 5 dx. Then dx is going to be equal to, by dividing by 5, I get dx is equal to du over 5. So I make my substitution. I've got the integral of sine of u, and where I see dx, I'm going to place it with du over 5. So now I've got a pretty simple integral here. I'm going to pull that 5 outside as a 1/5. The antiderivative of sine is negative cosine, so it's going to be negative 1/5 cosine of u plus c. And for my last step, I'm just going to plug 5x in for u. So I have negative 1/5 times cosine of 5x plus c. Now you really could just jump from this step to this step right here, and you can do that when the derivative of the inner function is just a constant. It only really works in that case. And you can just recognize the antiderivative of sine is going to be negative cosine, and so you keep the 5x as your inner function, and then how you get this negative fifth out, or just the 1/5 outside, when the derivative of the inner function is a constant, again, it only works for that, you can just divide by whatever that derivative is. So in this case, the derivative is 5, we divide by that, that's where we get the 1/5. So that makes an easy way to skip from here right down to here. Alright, so another U-sub one here. There's a lot of different ways that you can U-sub, a lot of different ways that you can use U-sub, that problems can look differently. And in this case, we have sine to the 4th of x times cosine x dx. In this case here, a lot of times people get confused on this, with whether to let u equal sine to the 4th x, whether to be u equals sine x, whether it's cosine x. And, if we let u equals sine to the 4th of x, we'd have to use the chain rule for the derivative, because you'd bring the 4 down in front, you'd subtract 1 from the exponent, keep the inner function. You get a crazy derivative there, so that's not going to work good. If you let u equal cosine x, the derivative would be negative sine, and it would cancel one of the signs, but we'd have 3 left, so that wouldn't work. So in this case, if we let u equal sine of x, the derivative is cosine, we only have one cosine to cancel, so that works really well. So let's go ahead and let u equal sine of x, and du is going to be equal to cosine x dx, just by taking the derivative. So that means that if I divide by cosine, I have that du over cosine x equals dx. Now I can make my substitution, and it's going to be fairly simple from here. So u goes in for sine, so I end up having u to the 4th. Cosine's going to stay there. My dx, instead of writing that, it's going to be du over cosine x. So I'm just going to go ahead and I'm going to cancel out my cosines, which is awesome, that's what you should do. So I'm left with u to the 4th du. Well, the antiderivative of that, simple power rule, just going to be u to the 5th over 5 plus c. And like I've done with all of them, I'm on my last step, I'm going to go ahead and take sine of x, and I'm going to plug it in for u. So it's going to be sine to the 5th x over 5 plus c is our final answer.